Hello everyone, we are team Oscillonauts from IIT Bhubaneswar, batch 2021.
I am Harshvardhan.
I am Arin.
I am Vishwajit.
I am Rahul.
And we are presenting our project Mini DSO.
This is the demo for our Mini DSO, and for this we are using a unipolar external ADC with the range of 0 to 5 volts. And to take negative values, what we are doing is we are adding an offset of 2.5 volts here, so we can make our range instead of 0 to 5 to minus 2.5 to 2.5. For now we have a square wave with amplitude 4 VPP, frequency 50 and an offset of 2.5. Upon changing the input from square to sine, we can see the same changes here, and likewise we can change it to a triangular pulse, and we can even get some noise here. Okay, we have implemented two ways of taking input. First, we can use external ADC that we are using for this demo, and other is we can directly use analog read from Arduino.
Okay, our DSO displays some basic properties of the signal. Like here you can see a minimum voltage, maximum voltage, then peak to peak voltage, then time period, frequency, duty cycle, voltage scaling, and time scaling. Let's compare the values which we get here, like which we have at the original values. And you can see here, like the frequency is 50 Hz and the amplitude is 4 with the offset of 2.5, and the duty cycle is 50-50. So there is it's a sine wave. So we can see the it's offset, so the voltages are according to this, and the peak to peak is same. And then we can see frequency is 50 Hz. We are plotting it in kilohertz, and the duty cycle is 50. And yeah, that's like the first potentiometer here is actually just the trigger level. Like we are using an edge trigger instead of using a constant trigger value of 0. We have an edge trigger. Like you can set the value of that trigger. Like if I change this pot, you can see that trigger level is changing. It's now decreasing, and accordingly we are getting a sine wave. And the next potentiometer is for voltage scaling. Like now we are sending the maximum value of the signal, so we can descale it, downscale it to we can see the like, and here we can see that okay, our scale is now at 0.5, the voltage scale, and if we increase it's 0.1. And okay, now we have other features like okay, we were shortage on the number of IO pins. Like our ADC was using I2C, and then we lost A4 and A5, which are I2C pins of Arduino, and then we have A0 and A1 use these two ports. And for other features, like other features, we did a DIP we used a DIP switch to configure the single analog pin to use multiple things. Like if you can see, if all three are 0, then we can vary with the time scale. Yeah, we can vary with the time scale. Actually the X position maybe have set differently, so before moving that I should have set it. So we can see the time scale is varying, and here you can see okay, now the time scale is thrice, and yeah, it's 1 now. And you can also, if I do this like 0 0 1, then we have Y movement, and if we do this, then we have X movement of our wave. Okay, now let's change the frequency and see what our DSO gives. And now we have at 60, and you can see exactly it is saying 60 Hz. Then so let's go on increasing. Okay, now we are at something around 170 Hz, and you can see the signal is not looking good. So the use of time scale now comes in. Like okay, I have increased the time scale, now you can see it's a proper sine wave now. And the white line which you can see, it's about the 0 level. And let's go on increasing more. You can increase the time scale accordingly, and you can always get a proper wave.